In the past, when we solved exponential equations, we solved them by taking the log of each side. So we're going to do the same idea, but instead of taking the log, we're going to take the ln of each side. So we want to isolate the number that's being raised to the exponent, and in this case, it's the one that has the e with it. So we're trying to get the e by itself. So first thing we're going to do in this case is minus the 2. So we have 4e to the 2x equals 14. Then we're going to divide out the 4. So we're trying to get the e by itself. E to the 2x equals 3.5. And then instead of taking the log, we're going to take the ln of each side. So when we take the ln, it's the same rule that applies, that the exponent is going to come down. So this becomes 2x ln e equals ln of 3.5. Now ln of e, a little side note, ln e is equal to 1. Okay, so the reason being, since the base of the ln is e, if you change this to exponential form, e to the first equals e. So ln of e is always 1. Since the base and the e are the same, they're basically going to cancel out, and you're going to have 1. So this I can actually cancel out. So 2x equals ln of 3.5. So I'm going to divide by 2. So I have my exact answer, which is the ln of 3.5 divided by 2. And then I have my approximate answer, which is going to be 0.626. So if we look at a couple more examples, again, you're trying to isolate the e. So we're going to first divide both sides by 2. So we get e to the negative x equals 10. And then we're going to take the ln of each side. And when I take the ln, the exponent comes down. So I have negative x ln e equals ln 10. Ln of e is going to become 1, so that's gone. I have negative x equals ln 10. So divide by a negative, x equals negative ln of 10. And if we find the approximate, it's going to be about negative 2.3. Okay, in the next one, we're going to, again, isolate the e. So subtract the 5. E to the 3x equals 10. And then we're going to take the ln of each side. So 3x ln e equals ln 10. Ln of e is gone. So 3x equals ln of 10. We're going to divide by 3. So x equals ln of 10 divided by 3 as my exact answer, and as my approximate, I have 0.77. Okay, in this last one, we have kind of like the opposite. So we're going to get the ln's to condense them into a single natural log. So first thing we're going to do is apply our exponents. So this is going to be ln of x to the 1/3 plus ln of 2 minus ln of 3 equals 3. Okay, I'm going to add the ln of x cubed and the ln of 2, so I'm really going to multiply them. And I'm going to change my rational exponent to be a radical. So I'm doing 2 times the cubed root of x, and I'm dividing by 3, since I'm subtracting ln of 3. And this equals 3. Once I have a condensed ln, I'm going to convert this to exponential form. So we're going to say e to the 3rd equals 2 times the cubed root of x over 3. So now we're just solving for x. So we're going to multiply both sides by 3. So we end up with 3e to the 3rd equals 2 cubed root of x. And then we're going to divide by 2. So I have 3e cubed over 2 equals cubed root of x. And then we're going to raise each side to the 3rd. So I end up with my exact answer is x equals, 27, because 3 cubed is going to give us 27. This is going to be e to the 9th. And then 2 cubed is going to give us 8. So we have 27 e to the 9th over 8. And if we approximate it, it's going to be about 27,347.91. Okay, so we're going to look at a couple more examples. So again, isolate the e. So I'm going to add 8. So e to the x over 9 equals 14. And we're going to take the ln of each side. So my exponent's going to come down. So I'm going to have x over 9 ln e equals ln of 14. Remember, the ln of e is going to cancel out because that's just 1. So I have x over 9 equals ln of 14. And then I'm going to multiply each side by 9. So the 9 is getting multiplied to the whole thing. So I'm going to end up having x equals 9 ln of 14. Or approximate, I'm going to have 23.75. Okay, so in the next one, I'm going to take the ln of each side. So the x over 2 comes down. Ln of e is gone. X over 2 equals ln of 5. I'm going to multiply both sides by 2. So I have x equals 2 ln of 5. And approximate that, it's going to be 3.22. So in this one, again, isolate the e. So we're going to subtract the 4. So we have e to the x over 5 equals 3. Take the ln of each side. So x over 5 is going to come down. Ln e equals ln of 3. Ln of e is 1, so that's going to be gone. So we have x over 5 equals ln of 3. And then we're going to multiply each side by 5. So exact answer would be 5 ln of 3. The approximate answer would be 5.49. Okay, and the last couple we're going to look at. So I have the ln of e squared over 2. So I can bring the exponent down, and I can make this 2 ln of e over 2. Well, I know the ln of e is 1, so that's really going to be gone. So I have 2 over 2, which is 1. Ln of e is just going to be 1. Ln of e to the 10th, I can do this 2 ways. I could equal it to x, and then I could change this to exponential. So I could say e to the x equals e to the 10th. So then x would be 10. The other way I could do this, I could bring the 10 down. So I can say it's 10 ln e. And since ln e is 1, it's just going to give me 10. And then the last one, the 3 is going to come down. So 3 ln e. Ln e is 1, so I just have 3.